Students, today we'll start chapter 2 of our science book, that is acid, bases and salts. It is for class 10 and it is quite a vast chapter where we will read about the acids and the bases, its natural property. Not only that, but also the salts and the reaction of salts on different matter, then the indicators and the few things related to this chapter. Okay, so without wasting time, let's go for this chapter. First of all, we will read the acid and bases and its natural property. Class, we have already read in the previous classes that acids and bases, they have the far differences between themselves according to their nature, right? So if we go for its just physical property, acids are liquid and the bases are quite solids and the semi-solid in part. Not only that, but also their tastes. Acids are where the soaring taste, but the bases are bitter in taste. Got it? These are the physical properties, and different acids have the different colors, whereas the bases are quite white or off-white in color. It can be seen in everywhere. Got it? And not only that, if we go for the chemical properties of it also, then we can observe that there are few of the things throughout our world which contains the acidic and the basic both part into itself. First of all, if we go for water, that is H2O. Now if we divide this water, then we will get easily the H plus ion and the OH minus ion. Okay, whereas the H plus ion is showing the acid parts, whereas it is showing the acidic part, whereas OH is showing the basic part. It means that acids and basic both parts are joined together and makes another components. What is that name? The name is the salt, right? So not only salt, but also it is said that whenever acid and the base both part are joined together by the reaction, then salt form. But salt is not that what we eat or what is used in our cooking. Got it? But also there are different type of salts also present throughout the world, and this process known as the neutralization process. You all know about it. So neutralization process, different things, different matters and water also are produced, and they remain in a neutralized way, so that they can contain easily the acidic and the basic part in a proper amount. Sometimes it also happens that somewhere the acidic part it increases and somewhere it is which is decreases. Somewhere it is also seen that basic part is increases but the acidic part is decreases. So it also vary according to the molecules or according to the protons, we can say protons of the unit part of any acidic or basic part. Okay, it means suppose I'm giving you an example, then you can understand in a better way. Got it? Okay. Okay, if we say that what happens to an acid or base in a water solution, when we give an acid part, first of all we will go for the acid part. Suppose I am taking here the hydrochloric acid, that is the concentrated and very strong acid. So hydrochloric acid, when I will pour it in water in a slow manner, at that time what will happen? You know that here it is H plus and Cl minus, both ions are present, and here also H plus and OH minus present. Okay, so what will happen here? Here the H2O means H plus and OH minus. Okay, and here is also H plus. So this H plus will add with this H plus and it will remain as H3O plus Cl minus. Okay, so H3O plus Cl minus, it means it is called as hydronium ion. Okay, it is the hydronium ion. So it means also that we can say that acids, when they are whether they are strong or weak, when they are added to the water, so automatically the hydrogen part or the cation part, it goes to the water and it mixed with it and makes another product. Got it? By its what do I say that dispersion process. By the dispersion process, they make the hydronium ion or H3O plus and Cl minus or the chlorine ion, it remain as usual. Got it? So in this way it happens. Next few of the things also we will read from this chapter, from this part, that is that not only this physical property, not only this reaction property, but also color also helps to understand that what is acid and which matter has or which substance has contains a lots of acidic part and which contains lots of basic part into it. Got it? And for that purpose, which things helps us to understand the color, that is the litmus. Okay, the litmus paper. And not only the litmus paper, but also there are different others colors are also present which contains the acid and the basic part into it. Through books you can read it before, and few names are also given over there, that is the litmus, and then the you can say that China roses petals, then you can say the methyl orange if you go for the lab, then methyl orange, then phenolphthalein. Got it? So all those things are present in the turmeric, all those things are present which helps to understand or shows the acidic and the basic of a property. Now the smell, not only the color but also the smell also says in different way. Suppose if you take the lemon juice, okay, and if you add the lemon juice with the acidic part and the basic part, any acidic property and the basic property, and if you mix it, you will get the different smell from there, from where it is very strong smell is coming, and from other property very weak or very foul smell is coming. So in this way different smells are also said of different type of property, whether it is acidic or the basic part. Okay, so in this way also we can distinguish between the acids and the bases. Now acids and bases in the laboratory. Yes, acid and bases are used in the laboratory in different way for making the different reaction process. Got it? And we take the acidic part, the basic part in proper test tube, and we just go for the experiment using it. Okay, next we can go for the how do acids and bases react with metals. If we go for the metallic part, okay, first of all if we go for acid to react with metal, okay, so what it will be, when acid and metals both will react to each other at that very time, they will form the salt. Okay, they will form the salt mainly, and the hydrogen gas, and whenever this hydrogen gas comes out, we know that a popping sound will come out from there. Okay, a pop sounds will come out from there. So if we go for the proper reaction process using different acids, suppose I am taking here NaOH plus zinc. Okay, then what it will be, Na2ZNO2, okay, plus H2, Na2ZNO2 plus H2. It means sodium zincate it will form, and the popping sound of hydrogen gas will evaporate from there, or it will emit from there. Got it? So it in this way the metals works or reacts with the acidic part. In basic part also it happens in different way. Next we will go for how do metals carbonates and the metal hydrogen carbonates react with acids. Yes, here also we will use the strong acid, that is the HCl. Okay, so metallic carbonates and metallic hydrogen carbonates. Metallic carbonates means we will take sodium as well. Suppose I am taking here Na2CO3 as it is metallic carbonate plus strong acid with acid. So what it will be, it will come as NaCl. I am just showing you what will come, which byproduct will come, NaCl plus CO2 plus H2O. Okay, so it will come, and the second one, it is the metallic bicarbonate or hydrogen carbonate. So same metal I am taking NaHCO3 plus the strong acid, that is the HCl. When I will react with these two, again it will come as NaCl plus CO2 plus H2O. Okay, so These are the products and these are the byproducts it will form for the both reaction process, whether it is the sodium carbonate or metallic bicarbonate with the acids. Okay, so in this way it will form. Okay, fine. Next we will go for how do acid and bases reacts with each other. Acid and base, we know that when acid and base reacts with each other it will form as salt. Okay, so let's go for it. NaOH plus HCl, it will come as NaCl plus H2O. Got it? So this is the exact reaction for showing the acids and base. When these work react together, then salt and water will form. Got it? And this portion is also under the neutralization reaction, because here if you take the strong acid, then the strong base, weak acid, weak base, and based on this the salt or the product will form. Now reaction with metallic oxide with acids, metallic oxide and acid, when it will form. Metallic oxide, okay, suppose I am taking here metallic oxide, so okay, Na2O plus, it is said with the acids, then what will come? Na2O and HCl, so here it will come as NaCl plus H2O. Okay, NaCl plus H2O. Look, salt has provided, salt has come as the main product, and H2O, water, has gone out. Got it? So metallic oxide, when it reacts with the acids, then automatically it will form as a salt and the water. Got it? So this is also a part of reacting with the metallic oxides with the acids. Okay, next reaction with non-metallic oxide. Non-metallic oxide means if you take Ca2O, CaO, okay, CaO, this slack lime, if you works with HC, with base, non-metallic oxide with base, CaOH whole 2. Got it? So here also salt and water will form in the same way. Next, what do all acids and all bases have in common? What do all acids and all bases have common? Look, acids means they have the H plus ion, and H plus ion means they are acidic. Okay, it contains the acidic part into it, and basic. All of the basic part, or the things those which are coming from the basic part, they have the hydroxyl ion or OH minus ion or Cl minus ion. Okay, so these shows the basic, these increase the basicity in a solution, and it is common for everywhere for the reaction and for every kinds of acids and bases. Okay, then what happens to an acids and bases in water solution? We have already read about it. And then if you go for, suppose it has given a strong HCl, and you have to make it dilute HCl. So how will you do it? We know that to make the strong acid into dilute acid, we have to add the water as a component. Got it? Suppose here is a strong acid, so a strong HCl is there and water is there. So whenever we will just mix it together, then it will make a dilute acid. But it's correct, but whenever we are just mixing it together, then we must not pour the water into acid. We will not pour the water into acid, so that the water can be splashed out, or the acids can be splashed out, and it could be harmful for our skin. Got it? So that's why we have to take a beaker, then water into inside, then one spatula we have to take, then through this acid we have to slowly we have to pour the acids, and we have to stir the water in the solution, so that whenever we are mixing it together, no splash can come out, and in a proper amount the dilute solution can be made. Okay, so in this way we have to make the strong acid into weak acid or the dilute acid. Next, how strong an acids and base solution. How can you see? We have used lots of strong acids and lots of strong base and weak base for reaction, but how can we say that the solution that we are using, it is what amount of strong is it and what amount of weak is it? We have to measure it, then we can say yes. For measurement, there is a kind of scale like structure that contains lots of numbers. Okay, it's a scale like structure. It helps to measure that a solution is either acidic or basic or neutral, or what amount of acidic is it, what amount of basic is it, or whether it is neutral. And this scale has lots of number. We know that scale or ruler means they have the numbers. So it is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so total 14 boxes are present. Whether you have to keep it in your mind that the 7 box means neutral, it is always neutral. Okay, and this side, it means the left side of it, of ours, it is acidic part, means H plus, and the right part, it is OH minus, means the basic part. Got it? It means 1 to 6 it is acidic, and whenever it will go from 6 to 1, the increase of the acidic part or the increase of the hydrogen molecule will be there, and whenever we will go for 8 to 14, there the protons or the molecules of OH minus will be increased. Okay, so in this way we will take out. Now how can we find it out? We cannot take this scale inside any solution and we cannot measure it out, but we have to take something to measure that acid or basic, whether it is strong or weak. So what can we do? Suppose I have taken strong HCl. Got it? A proper strong HCl. I'm not telling a strong or weak. Okay, it's HCl acid I have taken in a beaker. Now what I have to do? I have to take a litmus paper. Got it? A litmus paper. Now whenever I'm pouring the litmus paper, you know that it will change its color from blue to red. Got it? Now as it is acid, so from that acidic part I will check the color by taking the litmus paper. Suppose these are the litmus paper. Okay, now whenever I have poured in the solution in the HCl, then what will happen? Suppose there the color has come as red. Okay, it has come as red in color, and here is also red in color. Okay, now what will I do? When I will check that through which column this color is matching, then obviously I will check that from number 2 this red and red color has already matched to each other. So I can say it is quite stronger, this acid is quite stronger, as through this pay scale it is showing the color as red in number 2. Okay, and we know that number 1 and number 2 means these acids are very much stronger. Okay, it means it contains lots of hydrogen ion into itself. Now if we take a base, suppose a soap. Okay, a soap, then I have just put the litmus paper over there, then it has turned into blue in color. Got it? So it has come as blue in color, and suppose in the 12 blue is written, then what will I do? I will just check from 8, no, 9, no, 10, no, 11, no, 12. Yes, in the 12 number column, this color and this color, this both color has matched together. Okay, it looks almost same to each other, they are resembles. So from there we can easily say that this soap has taken excess amount of base into itself. Got it? So that's why it is blue in color, and through this scale this has come at the 12 number column. Got it? It shows the 12 number color. So in this way we can check out the color, or the sorry, the strong strengthness and the weakness of an acid or base. And do you know what is the name of the scale? This scale's name is pH scale. pH scale. Here the P, the word, is a Greek word. It has it is known as potence. Okay, P for potence and H for H plus, or the acidic part. Means according to the increasing of the hydrogen ion or decreasing of the hydrogen ion, the color will change like this. Okay, and the colors are like just like the VIBGYOR it comes. So V, from here we can say VIBGYOR. So in this way VIBGYOR color will form, and it is there in the pH scale. And through pH scale, everyone used to try out that which acid and which base is coming from which number, and how much strong is it or how much weak is it. Understand? So it is all about this pH scale. It is there in your book, you can understand it in the proper way from there. Next, importance of pH in our everyday life. We have already read in class 6 also, maybe in class 6 also. Then whenever ant bites, then what you have to give. Whenever any sting has wounded you, then what you have to do, each and every part. In the same way, few of the examples are also given there that happens with our daily life. That is, number one, are plants and animals pH sensitive? It is said that plants and animals have the pH. Of course they have the pH, okay, as they takes the water, and we also have the water and lots of foods, and those foods contains lots of pH, which means acidic part and the basic part in itself. Suppose if we take the orange, then it contains lots of acid into itself. Got it? When we take the curd, it also contains lots of acid into itself. Got it? So in this way, different fruits are also present over there, which contains the base into itself. So just like pear contains the base into itself. So in this way, the acid and base takes by ourselves, not only ourselves but also plant's body, and it gives the neutralize. It neutralizes our body and helps to digest properly. Okay, not only that, but also when it is said the acid rain, we know that acid rain, why is it? Because the oxides of the sulfur and the carbon, when it increases at that very time, the rain happens, and those rains are known as the acid rains, and those acid rains are quite affected the crops. Okay, next, what is the pH of the soil in your backyard? Okay, if you go for your surroundings in the soil is so how much acidic or how much basic, you can try it out through the experiment. Then pH in our digestive system, I already told. Okay, acidity, when we feel the acidity, then when the hydrogen ion increases in our stomach, at that very time acidity comes, and that very time we takes the magnesium hydroxide or the milk of magnesia to mild it. Okay, next, pH change as a cause of tooth decay. It is said that whenever you are chewing the food, and after having food, few of the food particles are kept inside the tooth, okay, in the middle of the tooth, that doesn't come out for a long time. And if you don't take the water, so all those things remain over same for a few times, and it used to change itself. Means this sugar has changed itself by the help of the salivary gland and the saliva. Okay, when it reacts with the saliva, then automatically this sugar helps to make a hole or a small hole inside the tooth, that is known as a tooth decay. So that's why it is said of all the time that after having the food, must take the water and must gurgle in your mouth, so that all the small parts can also goes out from the middle of your teeth. Next, self defense by animals and plants through chemical warfare. Okay, you will observe that the what do you say, few of the plants are there, which contains the spikes or the spines around its body, and if you accidentally touch them, so all from these spikes an acid used to secrete, and all those secretion helps to make a wound of your body. Okay, so this is a kind of the self protection by the plants. Got it? Now if you go for a few of the animals, just like the porcupine, okay, and if you go for the what is the name of it? I'm just forgetting. So the creatures that contains the spines around its body, they are also quite dangerous for ourselves. If you touch them, so easily they can wound you, and through that acids also few wounds comes on your body that could be affected. Okay, so in this way, for self-defense also, plants and animals contains the acids in their body. Few of the plants and animals, not all. Okay, now we will read the more about the salts. We have read about lots of configurations and the reactions around the salts, along with the salts and the pH balance of themselves. Now few more about the salts. Through not all these, but also what can we do with the salts. Okay, salts, it says the pH balance of the salt means how can we take the pH, how can we say the pH of a salt. Look, we have already told that whenever we are using the acids or base, first of all we have to understand that the acid or the base is um, strong or weak. If it is strong, then the reaction will be in different way. If it is weak, then the reaction will be in different way, and their temperature that will come by the reaction process, it will be also different from the strong acids and from strong base. When they make the product, so automatically a temperature will come out. Okay, but when the weak acid and weak base will react to each other, and from the product a very little amount of temperature will come, or no temperature will be there. Got it? So it also vary over there. And for this purpose, when we go for the reaction process in the laboratory, suppose you are taking the strong acid, okay, and the strong base, the strong acid and strong base, when you are taking and you are making the reaction, so automatically when the salt will form, that salt will be the strongest. Got it? Because it has contains the strong acid and strong base. Now, so it will be neutral. Got it? Through pH balance, if you go, so strong acid plus strong base, when they will come and join together or react together, then the now if you take the strong acid and the weak base, so what will happen? The strong acid means they contains the lots of hydrogen ion in itself, and OH is quite minimum in amount because it is weak base. So strong acid plus weak base. So let's write here. Okay, suppose strong acid plus strong base, so the salt will be strong. Okay, salt will be strong means strong. So sorry, salt will be neutral. Salt will be neutral. Got it? Now if you take strong acid plus weak base, strong acid and weak base means maximum amount of hydrogen ion, minimum amount of OH ion, so it will come as the salt, but it contains lots of H plus ion because excess amount of H plus ion is present. Now if you take weak acid plus strong base, okay, very weak acid and very strong base, then what will happen? Salt will must form, but it will contains lots of OH minus into itself. Okay, so in this way, the salt, the reaction process and the product after reaction of the salt and after reaction of the acid and base, it will form, just vary on this, on its strength and the weakness of its. Okay, next, chemical from common salt. Chemical from common salt, how can we make? It will be discussed on the next day's class. Okay, so read well from the book and watch my video. You will understand everything. Thank you.